Welcome to Session 5 of our Maths training on CPA. This presentation will be delivered by myself, Kirsty Kilpatrick, and my colleague from the Early Years Teacher Team, Cheryl Jackson, along with Erin Scott, SBC Curriculum Lead for Maths and Numeracy. Thank you.
So before you proceed with the training session today, there are some key resources that we would definitely recommend having out in front of you. And these are 10 frames, bundling sticks, Dean's materials, also known as base 10, place value counters, both whole number and decimal, Numicon, Cuisenaire rods, and Rec frames and or bead strings. So the structure of this session today will follow a similar format to that of our other professional numeracy training sessions. So we're going to have some core input around some of the different CPA resources and approaches. However, within that, we've got some different practical activities for you to engage with within your staff teams. At key points throughout the training, we've got reflective questions where you can consider your own practice and just think about sharing good practice within your staff teams. And then towards the end of our training, we've got some follow-up activities around considering your planning and then thinking about the digital approaches that support CPA development. But hopefully these different elements are going to lead to some new understanding or maybe just a refresher or some new ideas around some of the key resources that we are recommending. So I hope you enjoy our session today as we proceed. So we're going to come on now to our school-based starter task. And we would like you to think about how many different ways can you represent the number 8 or 39 or 573 using concrete manipulatives or pictorial representations. So you can use all the different resources in front of yourself, you can draw visuals or diagrams, but if you could just pause the video now and spend the next 5 minutes drawing as much as you know about one of these numbers and choose the number that's most appropriate to the stage that you're currently teaching in. Thank you. Thank you very much for completing the starter task in your staff teams. So on the screen, you can see just some examples of how you maybe could have represented the number 8, both with concrete materials or pictorial approaches. So hopefully some of these things you came up with, whether it be the part whole model, maybe the 10 frame, maybe demonstrating that on a number line, and then there's some other kind of everyday objects and things that have appeared within that, demonstrating the actual calculations you might have come up with. So hopefully that's just given a few different types of ideas. So if you chose the number 39 on the screen in front of you, you can see some of the different ways with concrete materials or the pictorial representations that you might have represented this number. So some of the things that you can maybe see are like the bundling sticks that we're going to come on and think about in our training today. The place value counters, you might have used those thinking about your 10s and your 1s. You might have again drawn that kind of part whole diagram. You can see there one with the 2 circles below it, or the 3, so it doesn't just have to be split in, partitioned into 2 different parts. We've got the 100 square there. So again, just thinking about the variety of approaches that you came up with in your teams. And similarly, if you chose the number 573, you can just see some different ways that's been represented. So we've got the Dean's materials this time coming in. Again, we've got those place value counters within that place value chart that can be a really nice addition to using alongside the place value counters. We've got the arrow cards. That's something that we are not touching on within this session, but are really useful to explore learners' understanding of place value. Again, on the screen, you can see the breakdown in some different types of calculations, and then that of a number line. And I'm sure you've come up with many other different examples as well within your teams. So that brings us on to our 3 key aims of our session today. So our first aim is to develop a deeper understanding of the concrete pictorial abstract approach and how this allows us to build learners' conceptual understanding of number. Our second key aim is to develop confidence around using a range of concrete approaches and manipulatives, and to consider practical strategies and different ideas and things you could do with each resource. And our third key aim for today is to develop an understanding of the different digital tools and approaches to support CPA development. So we're just going to start with a short overview on the CPA approach. So it stands for Concrete Pictorial Abstract. Sometimes you might also actually see it with an L as well. If any of you have read the book by Mark McCourt on Teaching for Mastery, there is a different model in there around CPA that also describes it with an L for language at the end. But the main key approach is CPA. It was developed by Jerome Bruner back in the 1960s, so this is not a new approach. It has been on the go for 60 years now at least. So many of us are familiar with seeing lots of the resources in schools and have been familiar with using many of the approaches over the years. But it is still really powerful, and we just want to kind of address why. So using the CPA approach really allows learners to build that conceptual understanding of number, that ability to make those visual representations, those ability to build those structures and models to support and deepen their thinking around mathematical concepts. It also really helps learners to build those connections between their mathematical thinking and think about those ways, those multi-representations of different mathematical ideas. So it's still really powerful. And the three key phases, so we've got the concrete, and we're going to come on and explore that in a minute. We've then got the pictorial, and then we've got the abstract. Now the key thing with these is it's not a linear progression from one phase to the next. What we really want to be doing is moving back and forth between these phases. And at points, you might be embedding more than one phase at once and showcasing those examples where you're seeing the concrete, you're seeing the pictorial, and then you're seeing the abstract with it. So that's just a little overview. And we're now going to come and really focus on today and unpicking around the concrete approaches. And then in our follow-up session, we'll be looking more at the pictorial side of things. So as you can see from the screen, there's an extensive range of concrete resources and approaches that we can use. And sometimes this makes it challenging for us as practitioners, because we kind of get, at some points, we're like, well, how many should we be using? Is there some that are more important or useful for teaching a particular concept? Is there a progression in terms of how I should be using the resources? And these are some of the things we're going to be thinking about and considering today. But I think it's just making sure that we are giving our learners the chance to experience and engage and interact with a variety of resources. And we're not shoehorning and pigeonholing them into only getting confident with one or two resources. And there's also so many lovely real life resources that we can use in relation to concrete approaches that we would really recommend and advocate using as much real life resources as possible, whether that be money or different kind of nice outdoor objects and materials. I realise the ones that you can see on the screen in front of you are more your man-made, your built ones, they're made of either plastic or wood. So again, that's just something to be mindful of. But the concrete is anything that we can touch, that we can manipulate, that we can actually physically see and use. And obviously you've got that kind of tactile element of it that's really going to support learners develop their understanding. So I just wanted to draw your attention to the fact that in our new progression pathway, we have this turquoise strip within each of our curriculum organisers. And this is the recommended CPA approaches that we would like you to think about and to consider using when teaching these particular concepts or those particular strategies. Now, there is quite an extensive list, and there is no expectation that you're going to have to use all these resources in depth. I think it's just looking at the list and thinking, what ones do you have accessible within your school or setting, and what ones really work effectively for your learners, and maybe trialling and having a really good go at unpicking what ones you find most effective. But it's just to let you know that that support is there as part of our progression pathway. So I'm now going to pass you over to Cheryl and Kirsty, who are going to take you through the first bit of our training today around subitizing.
We are now going to go on to talk about subitizing. What is your definition of subitizing? What current level of understanding do you have? How is it relevant to learning in the stage that you teach? Pause the video here to discuss. Subitizing is the ability to know the number of items without counting. Subitizing starts in early level with the ability to quickly recognize visual patterns associated with numbers. This builds a deep understanding of number knowledge, which in turn supports the relationships between numbers and number processes, for example, addition and subtraction, multiplication and division. Babies and very young children instinctively subitize up to 3 items, but we need to give children lots of practice subitizing quantities before we move on to formal counting of items. This helps children to understand the concept of the number, for example, the fourness of 4. Perceptual subitizing is seeing the whole amount instantly, without counting. You use perceptual subitizing when recognizing the quantity of dots on dice or dominoes, regular dot patterns. If I look at a 5 on a dice, I just know that it's a 5. I don't need to count it. That's perceptual subitizing. The arrangement helps children to recognize the quantity. Numicon 5 and 10s frames also work in this way. However, focusing on just dot patterns and dice patterns does not fully develop this perceptual subitizing skill enough. Children need to experience subitizing small amounts in irregular and random dot patterns. Conceptual subitizing is seeing a larger amount as smaller parts, then putting those small parts back together to identify the quantity there. Look at the picture of the mushrooms. What do you see? 5 mushrooms. How do you see it? A 3 and a 2. We conceptually see the smaller parts and put them back together to make the whole. Now look at the pine cones. What do you see? 6 pine cones. How do you see it? A 1, a 1, a 2 and a 2. We know that this makes 6. Children need to experience subitizing using a variety of situations with a variety of resources. In order to keep the cognitive load low, use items which have similar shapes, colours and sizes, for example pine cones, trees outside, buttons, counters and cubes. Begin with working with numbers to 3 and asking the question 3 or not 3 to help children understand that they don't need to count each time. Rather than counting 1, 2, 3, talk to the children about here's 1 and another 1 and another 1 and altogether we have 3. Once they have this conceptual subitizing, children need to progress to flexible subitizing where the items are not arranged in a standard pattern. Ask, what do you see? I see 6. How do you see it? I see a 3 and a 3. When reading stories, for example, rather than asking the children to count the number of items on a page, ask how many they see. It can always be checked with counting afterwards, but children need practice identifying quantities in different arrangements. Subitizing is the foundation of number sense and the idea that number is all about patterns. It may start in early level, but you'll see from this visual that recognizing how numbers fit together or can be split is the basis of early addition and subtraction, and how working with groups of numbers links to both multiplication and division. The concept of whole and parts is the basis of understanding fractions. If children are visually secure, then they have the foundations for understanding number processes and applying this knowledge.
As we said on the previous slide, giving children lots of experience of random dot patterns first, before regular dot patterns, should mean that they are then able to quickly recognise the fixed shapes of regular dot patterns to represent a given number, without the need for counting. If they don't, clearly they need lots more opportunities for what do you see? How do you see it? What is the same? What is different? What do you notice? Regular dot patterns on dice and dominoes can be used to build children's number sense. Experience of playing games like snakes and ladders and dominoes are the best way of building this knowledge. Adult interactions are very important to develop that supervising knowledge, asking the children what they see. Do not tell them to count the dots, as this encourages an over-reliance on counting to check, especially if they just lack confidence. If the child is unsure, you can just tell the child the number value to avoid constant counting, which detracts from the game or intended learning. It is through regular experience and exposure to these patterns that the supervising will become automatic. You can use dot pattern labels in your spaces to support children organising resources, for example at tidy time in the block play area, or to check that there are the correct number of pairs of scissors at each table, and so on. Start with a 5 frame. These can be used as concrete materials using real objects or abstract using visual dots or images. One cell always represents one unit. To ensure low cognitive load, use the same colour or same size of counter or dot, for example, all yellow counters or all black dots, so that children focus on the quantity rather than the contents of the cell. Fill cells systematically from left to right or bottom to top. Explain the concept of full or not full, or finished and not finished to begin with. And then look at subitizing, which is naming the amounts, not counting the squares or counters. If a 5 frame becomes full, then put another 5 frame beside it. Use a maximum of 2 5 frames to make a 10 frame. Never have 3 because we work in base 10. For more information, see the Early Years Maths training on subitizing and finger patterns on the Early Years portal. 10 frames can be used to support routines like self-registration or lunches. Names can be put on dots and children fill the 10 frame to show their choices. Talk about the quantity already there and how adding one more will give the new total. Talk about the frame being full and the number of spaces until that frame is full. You can then write the number of children present or having each colour of lunch corresponding to the 10 frame counters. Highlight the tens and ones being the same as the number of full 10 frames and not the full 1. For example, 28 is 2 full 10 frames, 20, and 8 not full frames. Storage of resources. 10 frames can also be used to support children keeping spaces tidy by displaying the quantities of different classroom resources. Pause the presentation now to consider how you currently use 5 or 10 frames to support your learners in developing their number sense. What else could you do?
It is now believed by experts in education and cognition that using your fingers to help you calculate will help your development mathematically. For many years, teachers and parents have discouraged children from using their fingers when doing maths and number activities. It has always been the goal to move children away from this reliance on their fingers. However, recent research has suggested that when children use their fingers, they're making concrete representations of an abstract idea which will support their understanding. Scientists have discovered that the brain sees our fingers even when we're not using them. Practitioners and teachers need to be encouraging children to use their fingers and to develop finger discrimination, the ability to tell which finger is which, rather than discouraging their use. To teach finger discrimination, we start with the growing finger patterns, which is when the child can see their fingers and counts each one as they raise it. They can do this copying an adult and then begin to do this independently. The next step is to be able to do this without looking. The child can put their hands on top of their head like bunny ears to grow their fingers, or might be able to count under the table without looking. Throwing finger patterns is when the children are able to bring their hands from behind their back with the correct number of fingers up, or put up the right number of fingers all at once. To begin, the child can mirror the adult, but then progress to beginning to be able to do this independently when given a number.
So there is definitely a recommended order of progression in relation to the concrete manipulatives that you would want to use in order to develop children's understanding of place value, or that of addition and subtraction. Kirsty has very kindly in depth discussed ways in which you can use 5 frames and then how that would develop into using 10 frames for both subitizing and then to support that addition or subtraction development. And in the next little section of our training today, we're going to explore bundling sticks. We're then going to move on and explore Dean's materials and then that of place value counters. So we're going to start with that of bundling sticks. So a bundling stick is any material, so it could be a lollipop stick, a coloured lollipop stick, a straw, that you have grouped together in a group of 10 and then attached with an elastic band. So bundling sticks can be really nice in that 10 can be broken apart. So either you could keep it together as a group of 10 or it could be broken apart into ones. And that's what makes it a really good prerequisite to going on to Dean's materials, because the 10 of Dean's unfortunately cannot be broken apart. But bundling sticks could be really useful for supporting children's counting development. So as you put down a bundle, you're asking the learner to say what they see. And you could be going up in tens, you could be then taking away tens, and they have to visually see what they say. And then you can also then start again to break that 10 up into ones so that you could be counting off the decade, both forwards and backwards. So we're now going to move on to 2 short practical tasks involving using bundling sticks. So I'm just going to share and read out the tasks, and then in your staff teams, if you could pause the video and have a little go. So for these tasks, we would like you to work with a partner, and you will need some bundling sticks within your pair. So for the first task, we would like one person within the partnership to start placing down the bundling sticks. And as they do that, we would like them to ask their partner to say what they see. And then, so this can allow you to involve counting up or backwards in tens on the decade, or you could make this more challenging by also adding in some ones. So counting forwards and backwards in tens off the decade or in ones. So that's task 1. For task 2, we would then like one person in the partnership to place down some bundling sticks. And they're going to ask their partner to identify how many they have. When the partner has identified, so say if it was 24, we would then like them to circle this number on 100 square. You could then repeat this with different numbers. To then make this a little bit more challenging, we would then like you to start adding or removing some bundling sticks. So you might then remove 2, you might then remove 10, but each time we would like your partner to work out how many there are and circle these numbers on the 100 square. So this is combining the concrete manipulative with also that pictorial approach of the 100 square. So if you could pause the video now and have a go at these 2 tasks in your staff teams. So we're now going to come on and explore that of Dean's materials. So Dean's materials are wooden or plastic blocks that are used to represent a number. So you have the 1000 blocks, the 100, the tens, and then the ones. Now these were created and developed by a Hungarian mathematician called Zoltán Dienz, who was born in 1916. And that's actually why they're called Dean's materials, because they're named after this Hungarian gentleman, which I actually didn't know until relatively recently. And they have actually been on the go now since the 1950s. So we're now into kind of the 70th year mark of Dean's materials being available. They're often also described as base 10, so that's what you might call them within your base schools. So I think it's really important to raise firstly that this isn't a new resource. This is probably one of the most widely used resources, maybe within the Scottish borders, that maybe teachers feel slightly more confident with. But today we would just like to go over some basics and give some practical tasks to have a wee go with. So Dean's materials can be really useful to try and build learners' conceptual understanding of number and that of place value. And what's really useful about Dean's materials is there's a size and proportional element which shows the different relationships between the different quantities. And that's not the case with like that of place value counters. So that's why we would strongly recommend using Dean's as the next progression after bundling sticks before coming on to place value counters. So we're now going to move on to a few practical tasks. So we're now going to move on to our Dean's practical tasks. So for this, you'll need Dean's materials in front of yourself, and if you could again work with a partner for these next few tasks. So I'll explain both tasks, and then if you could pause the video and have a go in your staff teams. So for task 1, we would like you to create the number 347. And then once you have done that, we would like one person within the partnership to start manipulating that number. So they could either remove some of the Deans or they could add some extra Deans. And as they do that each time, we would like the other partner to say what they see. So that's task 1. If you have either a place value chart, you're very welcome to use that, or you could use like a cherry diagram. Again, that's really nice, bringing in those pictorial approaches to support you with using the concrete. Task 2, we would like you to then go on and create the number 3,256. And then from that, we would like you to now add 100 and write down your new number. Add 20 and write down your new number. And then we would like you to subtract 8 and write down your new number. So if you could pause the video now and have a go in your staff teams. Thank you very much for engaging with those practical tasks. So both task 1 and 2 could be used as a really nice little starter or a nice little warm-up just to build learners' understanding of place value, to deepen those connections. Maybe we were making those links, as we said, with the place value chart or your cherry diagram, and that ability to partition those numbers into your hundreds, tens and ones. It's also really nice to allow learners to see that addition and subtraction, those coexisting within the same time as part of the same warm-up. So we're really building on that mental agility, as well as learners having the opportunity to use and visually see that concrete resource. So we're now going to come on and explore a little bit more about using Deans within addition and subtraction. So we're now moving on to our next practical task with the Dean's materials. So discussing with a partner, how would your learners tackle one of these calculations? So either 28 add 47 or 328 take away 69. So once you've had a little discussion around that, we would then like you to use the Dean's materials to calculate this addition or subtraction question. We would like you to consider the key steps that the learner will undertake. Think about any challenges or pitfalls that there might be, and then consider how would you extend this learning, and maybe considering a discussion around the range of strategies that your learner might use. So if you could pause the video now and carry this out in your staff teams. Thank you very much for taking the time in your staff teams to unpick both those calculations. So we're just going to have a little think about the calculation of 28 add 47. And there's obviously a variety of different strategies and approaches as to how you could tackle this. So one of the key ones with using the Deans would be to partition it into the place value parts. So you've obviously got your 20 and your 40, and then you've got your 8 and your 7, which are your ones. With your Deans, using again the place value chart can be a really nice way for learners just to see the different Deans materials in the different columns and to be thinking about that. So we'd really strongly recommend using the place value chart alongside the Deans materials to support that development, that place value understanding. But there's obviously lots of other strategies that learners might have thought of, or you might have discussed within your staff teams. So you could have partitioned those numbers into slightly different ways. Some of you might have thought it was easier to actually partition the 28 into a 25 and a 3, and then add the 3 on to the 47 before adding the 25. And you might have thought that actually using a number line is a really powerful way and a strong way to do that. Or it could have been that you added the Dean's materials, but that you counted on using the Dean's rather than to partition into place value parts. Another way you can see there is that compensation, where actually you have changed the calculation. So instead of it being 28, add 47, you add a 2 on to the 28 to make it 30, and that actually takes that 47 down to 45, which makes it much easier to manipulate and to then calculate the total of 75. So yeah, hopefully that provided just quite a lot of discussion. We could obviously spend our whole CAT session or in-service session today just exploring addition and subtraction strategies. And that isn't actually the purpose of our session today. But I'm just going to come on now and show you the progression pathway. So building on what we were just discussing in the last slide, our progression pathways at both first and second level very clearly outline the recommended strategies that we would really like learners to have experience of, have the opportunity to interact with and to try for each particular phase of our progression pathway. And there's some support and guidance within this, different examples and different ideas around that. And obviously some of the different concrete and pictorial approaches will work really well for some of these different approaches. So it's just kind of taking the time off the back of our session today to think about what key ones really work well for using the Dean's materials, that partitioning into place value parts, but is there other things that could be really useful for? So again, just to make you aware that the strategies are really broken down within our progression pathway to help and support. So we're now going to move on and explore that of place value counters. So place value counters would be the next progression on from Dean's materials. In that it's slightly more abstract. You don't have the changes in size to demonstrate the quantity or the size of the number like you do with Dean's. All you really have is you have the number on the coloured counter, and each counter has a different colour. But sometimes with different brands, the colours can change. So again, that's something just to be mindful of. But these can be a really useful tool when you start working with larger numbers, because sometimes when you move into the thousands for place value or addition and subtraction, sometimes Dean's materials can get a little bit clunky because you're maybe limited in how many thousand blocks you have. So that's where place value counters can be a really useful resource. We would recommend using them in a similar fashion where they're highly accessible to learners. Learners can learn to build and represent different numbers using the place value counters. You can then obviously add and subtract quite quickly with using them. And then we really want to encourage that these are used alongside teaching the different strategies, whether that be a horizontal algorithm or a vertical like standard algorithm, that learners actually have the opportunity to use these and manipulate these as they're doing the calculation. The other thing that's worth sharing is there's also a decimal version of place value counters. So again, really good when you start working with building learners' understanding of tenths, hundreds and thousandths. So we're now going to move on to our next practical task involving the place value counters. So we would like you to use the counters to complete one of the following calculations. So either 147 add 169, or 8,423 subtract 3,211. And as you're using the counters, we'd like you to think about what are the key steps that the learner will need to undertake to complete these calculations, and what are the challenges or what are any pitfalls. And once you've done that, it's worth thinking around what other strategies might the learner use to work out these calculations, and just discuss that now in your staff teams. So we're now moving on to our next practical task using decimal place value counters. So working with a partner, we would like you to firstly create the number 3.4. So once you have done that, we would then like you to add 0.2 and write down your new number. We would then like you to add 1/100th and write down your new number. We would then like you to subtract 2.4 and write down your new number. And each time, can you add or take away the actual place value counters before you write down your number? So if you can now pause this in your staff teams and carry out this task with a partner. So we're now going to move on to explore that of Numicon, and we'd like to start with a reflective task in your staff teams. So we would like you just to consider and reflect on what are you currently using Numicon for? What concepts are you using it to support? So if you could pause the video now and just discuss this in your staff teams for the next few minutes.
Numicon is probably one of the most widely used resources at the moment. You may be using it already, or you might have done the Numicon training, or it might be something that you have but you're unsure how to use effectively. Numicon uses physical tactile shapes to represent number, making abstract concepts more concrete and easier to understand. Numicon is multisensory and lends itself well to learning through play. Children can explore Numicon and develop their number sense. Numicon can be used for a wide range of mathematical concepts such as counting and number recognition, addition and subtraction, multiplication, division, place value, fractions, decimals, patterns, and sequences. While Numicon is a fantastic tool, it's only one tool and should not be used as the only manipulative to represent number. Numicon number representations are fixed, so a 5 will always look like a 5 on Numicon. Children must also learn to subitize and recognize 5 in other irregular ways. Talk to children about the pieces as their value. Never get the children to count the wholes. This is a 1, or this is a 5, or this is a 10. They need to become familiar with the values of the pieces and develop a visual image of that shape.
Thank you very much, Cheryl. So as Cheryl's highlighted, Numicon can be an effective resource for allowing learners to really develop that foundational understanding of number and to develop their subitizing skills. It's a really nice way for learners to start to build those number stories and think about those different ways that you can make and break a number. You can see on the screen in front of you the Numicon staircase. So if you would like to start building that now as you're listening, that's no problem. What's quite interesting with the staircase, so as you're building it, you can see that the Numicon pieces are placed horizontally, so like the 1 and the 2 piece, rather than vertically, and that's quite important in the way it stacks in a pairwise pattern, is what we would call that. And what's really nice about then how your staircase builds is then it's very clear and easy to see the even from the odd numbers, because you can see that the odd numbers have the 1 additional piece at the top. So yeah, some really nice little strategies for using with your learners, getting them confident with Numicon. So on the screen in front of you now, you can just see some other nice examples about how Numicon could be used at early level or into first level, and thinking around the use of tough trays. So you can see in one of the tough tray examples, we've got thinking about building teen numbers. So again, a really nice use of Numicon. In another example, you can see, like we kind of spoke about in the last slide, those even and odd numbers and comparing them can be a really nice use. And actually in the other tough tray, you can see how they've linked it with time and that ability to start thinking about time scales and understanding what number each Numicon piece represents. We're going to come on now to our first kind of early level practical task, and that's thinking about the really nice link between Numicon and using the part whole model. So we're going to come on to that on the next slide now. So that brings us on to our first practical task with the Numicon today, which is focused at early level. So working with a partner, we would like you to create some small cherry diagrams, and then using the Numicon, we would like you to create the number bonds to 10. So if you could just spend a few minutes working with your partner and building the different number bonds to 10. So that brings us on to our second practical task. So as Cheryl mentioned, Numicon can be effective for exploring that of multiplication and division and thinking about those relationships and those properties. So we would like you to have a go at using the Numicon to demonstrate that 4 times 5 equals 20 and that 5 times 4 equals 20. And as you're doing this, think about how you could visually show this to demonstrate that law of commutativity. We would then like you to go on and repeat this for 3 times 8 equals 24 and 8 times 3 equals 24. So if you could pause the video now and use your Numicon pieces with your partner to build these. Thank you. So in the last practical task, we could see that Numicon can be highly effective for supporting learners to develop their understanding of multiplication. So we now want to think about how could we extend this, so thinking about that into second level. So we'd now like you to use the Numicon to demonstrate the factor pairs for the number 8. So if you could pause the video now and have a go at this in your staff teams using the Numicon. So we're now going to move on and consider the use of Numicon in relation to fractions and percentages. So what we would like you to do is, if you have a Numicon pegboard with your partner, we would like you to fill it with the different Numicon pieces. If you don't have a pegboard, you can still take part in this task by just building a 10 by 10 grid with the Numicon. And as part of that, could you please ensure that you have some pink pieces and some yellow pieces included? Thank you very much for completing your coloured pegboard. So we would now like you to focus in on your pieces of pink Numicon, and we would like you to work out how much pink do you have as a fraction of the total. So we would like you to write that as a fraction first. We would then like you to think about this as a percentage. So what percentage of your pegboard is pink Numicon? And we would then like you to compare this to the quantity you have for yellow Numicon. So if you could pause the video now and write down and discuss your answers in your staff teams. Thank you very much for engaging with those practical tasks. So on the screen in front of you, you can see how that practical task could be set up within a tough tree at second level. This can be a really nice way for starting to explore with learners what a percentage is, because it's an amount out of 100 and because the pegboard is based on a 10 by 10 grid. So again, yeah, it can just be a really nice task to do with your learners. The other things that can be really nice are to start thinking about how you can use Numicon for developing learners' understanding of a fraction, whereby the pieces of Numicon can be used as the denominator, and then the Numicon pegs could be used to represent the numerator, or another piece of Numicon sitting on top. So it's just a couple of examples on the screen to show how you could use Numicon to support with fraction development. At second and third level, Numicon could also be effectively used to support learners' understanding of perimeter and area, and you can see some different examples on the screen in front of you as to how that could be used. But again, just a really nice visual practical tool to help support their understanding. So we're now going to move on and explore that of Cuisenaire rods. So the Cuisenaire resource can consist of a few different elements. So you have the actual coloured rods themselves. So you can either get these in the kind of maxi rods, which are the kind of bigger, more jumbo size for younger learners, or you can get them in the smaller size, and these might either be wooden or plastic. You then get the blue tracks that you can see on the screen in front of you that can support the use of Cuisenaire rods, but it's not essential that you have these, and there's so many different great things that you can do with Cuisenaire without needing the tracks if this is something your school doesn't have. It's also really useful in kind of first and then into second level to actually have some 1 centimetre squared paper to use with the rods and to start bringing in as part of your work with Cuisenaire, because there is that relationship between the length of the rod and centimetres. So again, that's something really interesting for your learners to maybe investigate and think about as part of the exploration. And then also, actually similar to that of Numicon, having a weighted pan balance can be really useful because there is that weighted element to both the Cuisenaire rods and the Numicon pieces. So that's maybe something that you've not thought about or used with these resources before. So a pan balance to show that equivalence and to start to work on that can be highly effective. So we're going to jump straight into our first set of practical tasks around using the Cuisenaire rods. So I'm going to read out the instructions, and then if you could just pause the video in your staff teams and just work through them together. So first of all, we would like you to take one of each rod, so one of each different colour, and build a staircase with the Cuisenaire rods. And then start to think about the numerical value of the rods if we were assigning them from 1 to 10. So what rod would be what in what value? Now we would like you to then, once you've done that, separate your Cuisenaire rods into evens and odds, and just think about the different colours that are even and the different colours that are odd. Okay, now we would like you to go on and group the following rods together, and then consider in discussing your staff teams, what do you notice? So we would like you to group the black and white rods together, the blue, green and dark green rods together, the yellow and orange rod together, and then the pink, red and brown rod together. So if you could pause the video now and complete these practical tasks. Thank you very much for working through those practical tasks. So on the screen in front of you, you can see the Cuisenaire rod staircase. And this is a really nice way for learners to start manipulating the rods, start exploring those relationships between the different lengths of the rods. What we would advocate is that in ELK and Primary 1, it is all just about that exploration, the playing. Kirsty's going to come on and share a little bit more in relation to examples around that. But it's from Primary 2 that ideally we want to start assigning that kind of numerical value to the rod, to start allowing learners to start using these for other aspects of their number work. In the other image on the screen, you can see that we have grouped those rods according to what you have just completed in your practical task. And what's really interesting is to think about these relationships. So you might have instantly noticed, oh, there's maybe actually a bit of a colour theme going on between the warm colours have been grouped together and then the cold colours and then the monochrome colours. That's maybe something that you picked up on as part of this task. You maybe also noticed that the yellow rod, which we're classing as 5, is half of that of the orange rod. Or if you had double 2 of the yellow rods, it would make the orange rod. So thinking about that mathematical language and that relationship between the rods. Other things that you might have thought of is you can then notice the relationship between the 2, the 4 and the 8, and then the 3, the 6 and the 9. And something that you might have come out with was that the light green rod is 1/3 of the blue rod, or the dark green rod is 2/3 of the blue rod. So again, it's about making all these relationships between the rods, and it's such a really nice task, and there's lots you can pull out of that with your learners. Interestingly, so why are the white and black grouped together? Well, the white rod has a relationship to every other rod, whereas the black rod doesn't actually have a relationship to any other rod apart from the white rod, and that's the rod that we have representing 7 here. So again, hopefully that's been quite interesting and something again you could maybe take back into the classroom with your learners.
This progression shows how to use Cuisenaire rods with children. Start by letting the children explore the rods independently. Observe what they notice and what they wonder. Then move on to looking at patterns. Research says that the link between children's ability to spot patterns is more indicative of later mathematical achievement than counting. It is vital that children understand that patterns repeat and are able to verbalise this, as well as what the pattern is. They may make patterns as part of their exploration and play. They need experience of making a wide variety of patterns. Try to challenge children to make patterns which are more complex than just yellow, blue, yellow, blue. Maybe get them to make circular patterns or growing patterns. Ask the children to create a pattern using 3 types of rod longer than yellow. Can they make the patterns again, but making it smaller than yellow? Cuisenaire rods are designed in families to try to enable the children to become familiar with numbers and especially the relationship between them. The red family consists of red, purple and brown pieces which represent 2, 4 and 8. The green or blue family, light green, dark green and blue, represent 3, 6 and 9. The yellow family, yellow and orange, represent 5 and 10. Then white and black are 1 and 7. 1 has a relationship to all, but 7 has a relation to none. Try not to attach a numerical value until children have explored and become familiar with the rods. This is suggested from the very end of P1 if a child is developmentally ready, but if not, can be introduced in P2. And finally, look at the numeric values. Children will begin to recognise the value of the coloured rods and can use this to support mathematical relationships such as doubling and halving, part, whole relationships. For example, 3 and 2 makes 5, so 5 take away 1 is 4, and so on.
So for our next practical task, we would now like you to take the yellow Cuisenaire rod, and then we would like to think about what different combinations can you make using the other rods to represent the yellow rod, and how many different combinations are there. So at early level, you might just be thinking about just the colour and pattern only. What are all the different combinations that you can make? At first level, you might be now thinking, well, you've assigned a numerical value to the rods, so what different calculations can you write next to these based on what you've created? And at second level, you could actually adapt this where you're telling learners that the value for the yellow rod is now not 5, but is actually 0.5. And then what value does that make the other rods? And then you could write the calculations that support that. So if you could pause this video now and have a go at this task in your staff teams. Thank you very much for taking the time to complete that in your staff teams. So quite often this might be referred to as Cuisenaire rod trains. That's maybe what you've come across this as before. But from the visuals on the screen, you can see how either they could be stacked just flat, so just horizontally, but they could actually also be stacked up vertically on top of each other. So it's interesting if any of you in your staff teams actually displayed them like that. But again, a really nice way for learners to start to unpick those relationships between numbers, thinking about again the pattern, the colour, so a really nice visual approach. There is lots more excellent strategies that you could use at both first and then on to second level around the rods, and if this is something that you would like more training or more input on, don't hesitate to reach out and get in touch with myself. I realise this has just been a quick overview around some of the kind of key practical tasks today, but there is so many more things that you can do with the Cuisenaire rods. So we're now going to move on and explore the use of the Rec and Rec frame. So the Rec and Rec frame was developed by a gentleman called Adrian Treffers, who is a Dutch man who was involved in curriculum research in the Netherlands. The actual word Rec and Rec frame, it translates to either counting rack or calculating frame. So that's actually what that word means. And Adrian Treffers developed the Rec and Rec as a useful tool to support and develop children's number sense. So that's the kind of primary objective of using it, is to develop number sense. The Rec and Rec has rows of beads. There is 10 beads in each row, and they're in the configuration that they're grouped in 5s. And the 5 is either coloured red or coloured white. And that is what makes it different to an abacus. So it isn't actually an abacus, and that's due to the coloured configuration of the beads. So there's two different types of Rec and Rec frames. There is a 2-row Rec and Rec frame, which has 20 beads, 10 on each row, or you get a 10-row Rec and Rec frame, which has 100 beads, and again 10 on each row. Amy Howe is a Canadian mathematics teacher, and over recent years she has done a power of research and work investigating and exploring the effectiveness of the Rec and Rec. And she's written a really useful book called Rec and Rec 101. And within this short book, it provides lots of guidance, lots of practical tips and ideas and strategies around how we can effectively use the Rec and Rec. So would highly recommend this book to really support you within your classroom to develop your skills around using this tool. So we're now going to move on and consider how using the Rec and Rec frame actually helps and supports the learner. Well, firstly, it allows that learner to develop that rich sense of number. And it does that by allowing them to build either a visual model or representation of that number. Because they're building the number in either groups of 5 or 10, and it's got that colour component, it really allows them to develop that understanding of how to make and break different numbers. So quite quickly after practicing, they will get to know that a 9 can be made up of a 5 and a 4. And that'll be quite clear and visual with the 5 red beads and then the 4 white beads. It's really effective for allowing learners to move away from counting in ones. And we know that a lot of learners get stuck on still using the count by one strategy when working within either number bonds within 20 or number bonds within 100. And that's something that the Rec and Rec frame, if you're finding that with some learners in your class, this is where this is a really powerful tool to try and help your learners move away from the count by one strategies. So it's really going to support with development of those addition and subtraction skills, that ability to count on from a known number, and thinking about those number relationships that we want our learners to become really confident with. As we're going to go on and look at in the practical tasks, it is a really effective tool and resource for allowing development of doubling and halving strategies and thinking about that with your learners. So if that's something that particular learners find challenging, would really recommend using the Rec and Rec. And it's also then a really powerful tool for allowing learners to demonstrate their mathematical reasoning, because they're having to explain and justify how they've worked that out. They're having to defend their solution, and really, it's so really building that strong number sense. So we're going to start today with talking through some of the key basics and things we need to think about when using the Rec and Rec frame. So if you currently have a Rec and Rec in front of you, feel free to kind of go through these and think about these as we are talking through them as part of this slide. So these kind of fundamental rules come from the work of Amy Howe and are found within her book Rec and Rec 101. So the first thing that Amy Howe advocates is that we should always start with asking learners just what they notice. So without asking them to do anything, and just take that kind of the class discussion, take on those points. So your learners might come out with things like they can see that there's different beads, they're in different colours, that they're grouped in fives, that there's white beads and red beads, that the beads are in rows of 10, and they might come out with other things that they notice. So it's a really nice first question just to put to your learners the very first time that you start and introduce the Rec and Rec frame. Then there's two kind of key fundamental rules. So rule 1 is about the ready position. Now the ready position for a Rec and Rec is to have all beads positioned on the right. So you would just ask your learners to do a tip and tilt and get all their beads on the right hand side, and then place the frame down. What you don't want to see are learners tilting them back and forth loads of times. It's important just to remind your learners to know that these are quite expensive and it's an important tool, and they just need to do one kind of tilt to get all the beads in the ready position. And it's really important when they're in this position to be really explicit with your learners that this represents 0. This means that there has been no change, and that's what 0 means. There's no change. And then the value or the number represented on a Rec and Rec is by the beads that have been moved to the left. So because we read from left to right, this is where our eye is looking first. So this is where we want to move the amount of beads over to the left hand side. So that is rule 1. They all start on the right, right for ready, and then we move the beads to the left. Rule 2 is 1 finger, 1 push. So Amy Howe kind of argues that this promotes subitization in our learners. So what we're not wanting them to do is to move 1 bead over at a time. Amy argues that the Rec and Rec, we want it to be an efficient counting or calculating frame, and if we're continually moving 1 at a time, then that's not very efficient. She recognises in her work that younger learners are obviously needing lots of practice of that 1-to-1 correspondence, but she advocates that learners could just put their finger on the bead, they can count along, and then say if you had asked them to show you the number 4, once they get to 4, they know that cardinality of number, they would just push the 4 beads over together to the left hand side. So that is what Amy advocates, and she calls that 1 finger, 1 push. So we're now going to move on to a few little practical tasks using the Rec and Rec frame. So for this, we would like you to work with a partner and have 1 Rec and Rec between 2. This could either be a 2-row Rec and Rec with 20 beads or the 10-row Rec and Rec. It's up to you, just depending on what your school and establishment have available. Ideally, Amy Howe recommends starting with the 2-row Rec and Rec, really to develop that number confidence and that number sense and flexibility within 20, and then allow for that movement up to the 10-row Rec and Rec, where learners then get excited that they're moved up to the bigger frame. But again, obviously depends on what is available within your school. So for task 1, we would like you just to practice getting all your beads in the ready position, where they are all on the right hand side of your frame. And then 1 person in the partnership, we would like you to move over 14 beads and practicing the 1 finger, 1 push strategy. And then the other person in the partnership, we would like you to ask, how do you know that it's 14? And get your partner to explain how do they know that they've moved 14 beads. Once you've done that, if you could switch, and then the other person in the partnership, could they make 14 in a different way? And then again, ask them, how do you know it's 14? We'd then like you to repeat this for some different numbers, so you could take this up if you have a 10-row Rec and Rec frame. And just do this a few times, just getting really confident with the one finger, one push, and explaining how you know that you've made a particular amount. So that is task 1. Task 2, we would then like you to come on and think about how could you use the Rec and Rec frame for teaching doubles. We know that that's really important within our first level progression pathway, and I just want you to have a wee think about how could you use the frame for teaching doubles. So firstly thinking about doubles 1 to 5, and then your doubles for 6 to 10. And then task 3, we'd like you to go on and think about how could you use the Rec and Rec frame for teaching near doubles, and thinking maybe about the calculation of 8 adds 7. What are the different ways you could do that with the frame, and how could you demonstrate that? So feel free to try different examples working with your partner, and pause the video now for the next 10 minutes. So whilst that was just a brief introduction to the Rec and Rec frame today, if this is something you're really interested in and would like to develop your skills further, this is a little link to the National Dyscalculia Padlet from the last year. And on this Padlet there is further Rec and Rec training and advice from Ross Gibson, who is the Edinburgh City Development Officer. So feel free to access that via this QR code. So we're now going to move on within our professional training session to give a very short overview around some of the key pictorial approaches that you might be using within the classroom. This is an area though that we're going to explore in much greater depth in our next professional hybrid training session. One of the key things we just want to advocate from the outset is we shouldn't be seeing it that the learner's now confident with the concrete manipulatives, so we're now having that linear approach and moving on to the pictorial approaches. As practitioners, we really need to be thinking about how can we combine, how can we embed the pictorial approaches alongside that of the concrete. So our learners are building that mathematical thinking, they're being able to demonstrate their and they're thinking in multiple representations. So we're going to move on now just to give a little short overview around some of the approaches. So there's an extensive range of pictorial resources and approaches that are available. And we would want our learners to be able to use a variety of different resources across different concepts. We would like them to be encouraged to make the connection between the concrete and the pictorial and be able to represent their thinking in multiple ways. So as you can see on the screen, we have 10 frames. Now this is an interesting one because we obviously explored this as part of the concrete resources. But if you have an empty 10 frame and you have the double-sided counters, that can obviously be considered as a concrete resource. But if you have the visual pictures or just the visuals, again, that could be described as a pictorial. So that maybe poses just a little bit of confusion with that as to how that's represented. But you can also see we've got the part whole models, which can either be a cherry diagram or actually a bar model is a type of part whole diagram. We also have 100 squares, we have empty number lines, and then we have the 100 dot squares or dot strips that you might be really familiar with if your school already use the SEAL approach, as that is reflected within that. But teachers can obviously use the pictorial resource to help model and support develop children's mathematical thinking and understanding. And we would really like children, as I say, to have the opportunity to engage with lots of different pictorial approaches. So within our new numeracy and mathematics progression pathway, within each curriculum organiser you will see this dark turquoise strand. Now this is the key recommended concrete and pictorial approaches that we would advocate are really powerful and really useful to help support and develop those particular strategies or those concepts. So on the screen in front of you, you can just see where the pictorial approaches have been highlighted. So hopefully this will be really useful just to kind of guide and support you with the key approaches to be using. So that brings us on to our next reflective question for today. So in your staff teams, we would like you to consider and reflect on what key pictorial approaches do you currently use within your practice and within your classroom. We would then like you to come on and discuss what is your current understanding of bar models and part whole models, and how frequently do you use these to support your teaching and learning. Both part whole models and bar models are something we're going to unpick in much greater depth in our next hybrid professional training session. So if you could pause the video for the next 5 to 10 minutes in discussing your staff teams. Once you restart, I'm going to pass you over to Roddy Graham, who's going to share CPA digital approaches.
I'm Roddy Graham from the Inspire Learning team, and we're now going to look at the concept of digital manipulatives and how they can support maths learning. These tools offer pupils a hands-on, interactive way to explore mathematical concepts, making abstract ideas more accessible through visual and practical engagement. And with the increasing availability of these tools on iPads, they are becoming a real essential resource within our classrooms.
But with the added advantage of being flexible and easily accessible online. They allow pupils to experiment with numbers, shapes, and other mathematical representatives in a virtual environment, helping them to deepen their understanding through exploration and experimentation. Some places that we suggest using are on screen now: Toy Theatre, Amplify's Polypad, DDAX, and my personal favourite, MathSpot. These tools can be used for a wide range of maths topics, from basic number operations and geometry to more complex concepts like fractions, algebra, and problem solving. So whether it's through virtual blocks, grids, or interactive number lines, digital manipulatives offer a dynamic way for students to engage with their materials. For pupils, digital manipulatives make learning more engaging and interactive, allowing them to visualise and manipulate mathematical concepts in real time. This can be particularly helpful for students who struggle with traditional abstract representations of maths. For teachers, these tools provide new ways to introduce, reinforce, and assess understanding of mathematical ideas. They can be easy to integrate into lessons to support differentiated instruction, allowing pupils to work at their own pace and with specific concepts they need to focus on. They are also extremely cost-effective, as the sites mentioned here are free to access and have a wide range of manipulatives on offer. So let's take a closer look at one of these sites and how you can use digital manipulatives to solve calculations. MathSpot is the brainchild of Jonathan Hall, a secondary maths teacher in England, and has been available to access for free for a number of years. He's put a lot of time and effort into the site, and it always has got new updates and tools to better support learning. Today's example I'm going to show you focuses on the wonderful place value counters tool. We'll use the earlier example of 147 plus 169 equaling 316 for this. So I'm going to disappear from the screen, but you'll hear my voice talking you through it.
So we're going to do a sum 147 plus 169 using our place value counters. When it says show, we're going to turn on table numerals so we can see the columns with the hundreds, tens, thousands, ones, etc. We're then going to drop in our counters. We're going to make 147 first. So we take 100 in the 100 column. We're going to do 4 tens in the tens column. And in the top left-hand corner, those are copy buttons where you can easily copy multiple counters. We're going to do the same with our 7 that are shown just there. So there's our 147. We're now going to add into that our 169. So 106 of our tens, again using that copy tool in the top left hand corner. And we've not got enough room to do it very neatly, so we're going to do our 9s going outside of the lines, but we'll still have 9 ones in there. Now, what you can also do is you can then group counters where you've got more than 9 of them in a column. So if we take this little box here, it'll highlight all of our ones, and when we press the group button, it turns 10 of those ones into a 10 counter. So we're then just left with our 6 ones counters to make our 16, and we will then move that 10 into the tens column. We can then do the same with the tens. So if we snip that and make sure the box goes around all of them and we group those, it's left with 110 but 100, which can be moved across to there. So our final answer is 316.
Thank you very much, Roddy. So that brings us on to our next follow-up task. In your staff teams, we would like you to spend the next 10 minutes exploring some of the key digital resources that Roddy has shared to help support you with CPA development in your classrooms. So this might include looking at MathSpot or Math Learning Centre or Toy Theatre, and the QR codes are on the screen for you to follow. So that brings us towards the end of our session today, and we just want the time just to sit back and reflect on our kind of key aims that we shared at the start. So we're hoping through our session today that you've developed a deeper understanding of the concrete pictorial abstract approach and how we can use that to really build learners' conceptual understanding of number. We hope that you've developed confidence and maybe other strategies or ideas in using the different concrete materials. And we hope you've also developed your understanding of the available digital approaches and digital CPA tools that can support you within your classroom. So on the screen, you can see a few key texts that have helped support and inform our thinking around developing our CPA session for today. So if you would like to go on and do any further reading or any research into any of these. The green book that you can see, Teaching Number, forms part of the SEAL series of books and really does break down a lot of those kind of early foundations of number sense and a lot of the kind of concrete approaches to be using. So it can be a really, really useful guide to support you with developing children's number sense. Thank you. So that brings us to the end of our professional training session for today. So I just want to take the time to say a huge thank you for your time, your effort, your energy that you've put in to the practical tasks and the collaborative professional discussion in your staff teams. I hope you found it useful and enjoyable working together and sharing good practice and reflecting on different ideas. It would be really useful. We are really taking on board all of your feedback from all of the sessions to try and make them stronger and to make them better and more useful. So we would really appreciate if you could click on or scan the QR code that's on the screen now and complete our short feedback survey. Thank you very much for your time.